Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Picard. We're on Unit 9, Video 5, which is solving rational equations again. Unit 9, Video 4 was also solving rational equations. These ones are a little bit more complex. But our learning target is the same thing. We want you to be able to solve rational equations. Okay, examples of some rational equations. Some of the ones we worked with yesterday, 1 over 5x plus, we'll say x over 3 equals 1 over 4x. Working a lot with monomials in your denominator. Okay, we solved those yesterday by getting a common denominator and then canceling out that denominator. Now I do it a little bit differently than Miss Meyer does, so if you like the way she does a little bit better, you can watch one of her videos or you can watch mine, either or, it really doesn't matter. Another one, which we're going to be getting into more of today, is where we're going to be using more factoring. Here's a binomial in the denominator, minus, we'll say x squared plus 2 all over x squared minus 1. This does factor into two factors, so we're going to have to do that today when we find our least common denominator. I'll say all over x plus 1. So a couple different examples of, here we're working with monomials, here we're working with binomials, and we might even get into a few trinomials. Today we're going to talk about extraneous solutions. That's when you solve your equation, your rational equation, and you might get one or two answers, and one of the answers or both of the answers don't work. Those are called extraneous solutions. When a solution does not work, when plugged back into the original equation. We always tell you to check your answers. Well, sometimes when you plug your answers in, they don't work. That would be considered an extraneous solution. A lot of these answers, like this one right here, if I have x minus 1 in the denominator, that cannot equal 0. So that means x cannot equal positive 1. But if I solve this equation and got an answer of positive 1, that would be what we consider an extraneous solution, because that would make this fraction undefined, therefore it's not a solution for the problem. And if that's all we got was an answer of 1, then we'd have no solution, I guess in this case. So we're going to talk a little bit about extraneous solutions. Eliminate, it talks about solve the rational equation, be sure to eliminate extraneous solutions. Well, the first thing I see when I look at this problem is I have more than one term in the denominator. And r squared minus 1, you can factor that, and we're going to have to factor that when we find our least common denominator. So just rewriting this, first of all, r, that's the same as r over 1, plus r squared minus 5. You don't have to factor the numerator. I can't factor r squared minus 5 anyway. But this is difference of perfect squares, r plus 1 and r minus 1 equals r squared plus r plus 2 all over r plus 1. So r cannot equal, what can r not equal? Well, look at your factors. I have an r plus 1 here and here. So that means r plus 1 cannot equal 0. If you solve this, you get r equals negative 1. That means if I get negative 1 for a solution, that would be an extraneous solution. We cannot use it. We also have an r minus 1. If you set that equal to 0 and solve, you'd add 1 to both sides. So if r equals 1, that would be an extraneous solution also. So basically we're saying this, r cannot equal 1 or negative 1. So let's find our least common denominator here and start solving this equation. I'm really not worried about the 1. If that was 2, I'd have to have a 2 as a least and part of my least common denominator. I have an r plus 1 here and an r plus 1 here, so I do need an r plus 1. Just one of them though, there's one in each of those fractions. I also need an r minus 1. There we go, r minus 1. So r plus 1 and r minus 1. Um, this first fraction over here doesn't have either one of those. So I'm going to have to multiply. I might have to rewrite this. See if I can slide this over. Oh yeah. Oh yeah, that worked out well. This has a denominator 1, this fraction right here. So I'm going to have to multiply by r plus 1, r minus 1, in order to cover my least common denominator. This already has an r plus 1 and r minus 1. Over here, we do have an r plus 1, but we don't have an r minus 1. So I'm going to have to multiply top and bottom by r minus 1. Okay, so here we get into a little bit of work. Foiling this out, I'm going to get r squared minus r plus r, and finally minus a negative 1. This is equal to r squared minus 1 because these two bad boys will cancel out. And I'm multiplying that by this r. So I'm going to use the distributive property now. And I'm going to get r cubed minus r all over. Multiplying the denominator by 1, I'm just going to get r minus 1, r plus 1, and r minus 1. So we FOILed this out first, then multiplied it by this r, and we get r cubed minus r. Plus, nothing changes here. Denominator stays r plus 1, r minus 1. Okay, we're going to do a little multiplying here, multiplying these two. In the numerator, I'm still going to have an r plus 1, r minus 1 in the denominator. So multiplying by my r's, I'm going to have r times this r squared times this r, I have an r cubed. This r times this r is going to be r squared, and finally r times 2 is 2r. Multiplying everything by the negative 1. Oh boy, I'm running out of room up here. Okay, multiplying everything by negative 1. I'm going to have a negative r squared. I'm going to have a negative r. And I'm going to have a negative 2. Now, combining all these terms, combining like terms, this is what I'm going to end up with. I'm going to have an r cubed. That takes care of this. There's an r squared and a negative r squared. They cancel out. 2r and negative r, they're like terms. That's just going to be plus r. And finally, minus the 2. Okay, so what? We got a least common denominator. What that means is this. I really just solve the numerators, add them together and solve that equation. So I'm adding this plus this on this side of the equal sign, left side. I'm going to have an r cubed, an r squared right here, minus r minus 5 equals r cubed plus r minus 2. Okay, if I get all my terms on one side, I'd subtract r cubed from both sides. They're going to cancel out. I do have an r squared here. So I'm going to try and get all my terms on that r squared side. So I'm going to subtract r from both sides over here, and I'm going to add 2 to cancel these terms out and get everything equal to 0. So I have the r squared. Negative r and negative r is negative 2r. Negative 5 and 2 is minus 3. This is a quadratic equation. You can use the quadratic formula, but it looks like it factors pretty easily. For r squared, it's r and r. It's just a general trinomial. Factors of negative 3 that add up to negative 2, well, that's minus 3 and plus 1. Now, my answers are going to be this. R minus 3, equals 0. And if I add 3 to both sides, I get r equals 3. There's one solution. R plus 1 equals 0. Subtracting 1 from both sides, I get r equals negative 1. So I got 3 and negative 1. If we go back up here, R cannot equal -1 or 1. Those would be extraneous solutions. So this right here is an extraneous solution, so you wouldn't write that as one of your answers. R equals 3 is my only solution for this equation. Very good. Extraneous solutions, once again, we got to factor this bad boy and break it down. The only factor I'm going to be doing is this, and I'll do it up here. X squared minus 1 is x plus 1, x minus 1. Here we have an x plus 1, here we have an x minus 1. Here we have both an x plus 1 and an x minus 1. So our least common denominator is going to have this, least common denominator. Here's one x plus 1, here's another x plus 1. So I do need an x plus 1. Here's an x minus 1, here's an x minus 1. Kind of works out nicely that those are the only two factors we need in order to solve this equation, to find our least common denominator. But x plus 1 cannot equal 0. That means x cannot equal -1. And x minus 1 cannot equal 0, so that means x cannot equal +1. So if I had a solution of 1 or -1, those would be what we call extraneous solutions. So I'm going to take this first fraction, 2 all over x plus 1, and I'm going to have to multiply to get a common denominator of x plus 1, x minus 1, and x minus 1. Numerator and denominator. Okay? Minus, right here, 1 over x minus 1. I have an x minus 1, but I'm going to need an x plus 1 in my denominator, so we're going to multiply by that. Equals, what are we left with? -2 all over, we already have an x plus 1 and an x minus 1. So that's good. Go ahead and multiply your numerators. I'll get 2 times x is 2x minus 2 all over x plus 1. X minus 1. Minus, we're just multiplying 1 times x plus 1, so it's x plus 1 plus 1, x minus 1 equals, and we just have the -2. And go from there. We have a common denominator. So basically, I'm just working with the equation in the numerator. You got to be careful with this negative. You're subtracting this whole thing. So it's actually 2x minus 2 minus the x and minus the 1 equals -2. There's no x squared terms here. That's kind of nice. The 2x and the -x are just x. Minus 3 equals -2. Adding 3 to both sides, I get x equals 1. And here's the deal. That was one of our extraneous solutions. X cannot equal 1. So you're not going to write, hey, my answer is x equals 1. You can't have it equal 1. That's an extraneous solution. So I just say no solution for this equation. That's number 2. Number 3, a little bit more complex. A lot more complex. Just factor in the denominators. Not too bad. You can take a 3 out of both these. That's 3 times n plus 1. This one right here, you can take out a 4. That's 4 times n minus 1. And then this last one, you can take out a 2, and that's 2 times n plus 1. So I know this. N plus 1, n cannot equal, well, what do we got? N plus 1 equals 0. That means n cannot equal -1. That would be an extraneous solution. We have an n minus 1 right here. That equals 0, so n cannot equal +1. That would also be an extraneous solution. But anyway, our least common denominator. We have some numbers. We have a 3, a 4, and a 2. If it was just 3 and 4, your least common denominator would be 12. And the 2 divides into 12, so I'm going to say my least common denominator is going to have a number, just the number of 12. I need an n plus 1, right here and here. So just one n plus 1 and an n minus 1 for this n minus 1 right here. So I'm working with the factored denominators, not these denominators. So I'm going to go ahead and get my least common denominator and go from there. So I got 7n times 3 times n plus 1. Okay. I want my least common denominator to be this, 12 times n plus 1, n minus 1. I have a 3. I'm going to have to multiply that by 4 first of all, and an n minus 1. Okay, next one, minus 5 all over 4 times n minus 1. I got to multiply by a 3. 3 times 4 is 12, and an n plus 1. And this is going to equal, what we got there, 3n all over 2 times n plus 1. Okay, first of all, I get that number 12. I'm going to have to multiply by 6 over 6 and an n minus 1. Because we already have an n plus 1. Okay, cleaning this bad boy up. Actually doing the multiplying. I'd probably multiply, give myself a little room here on top to work. I'd multiply 7n times 4, that's 28n. And then I'm going to multiply that by the n minus 1. So I'm going to get 28n squared minus 28n all over 12, n plus 1, and minus 1. Minus 3 times 5 is 15, so it's 15 times n plus 1. That's going to give me 15n plus 15 all over 12, n minus 1, n plus 1. Equals 3n times 6, that's 18n times the n minus 1. So I'm going to get 18n squared minus 18n all over 12, n plus 1, n minus 1. So the way I've taught you is once you get common denominators all the way through your equation, you can go ahead and just solve the numerator. Now remember, you're subtracting the 15n and the 15. So I'm going to get 28n squared. 28n squared. Boy. I have a negative 28n, and this is a negative 15n, so that's a negative 43n. And finally, that's just minus 15 for this 15 right here, because it's minus a positive 15 or just minus 15. Equals 18n squared minus 18n. We have a quadratic. We have n squared here, n squared here. They're not going to cancel out. I'm going to get them on one side. Minus 18n squared. Minus 18n squared. I'm going to add 18n to both sides. These cancel out. Everything's equal to 0. The n squared, that's going to give me 10n squared minus 25n when we add these two together, and minus 15. And this is all equal to 0. Okay. Quadratic. Looks like it's going to be kind of difficult to factor. But I do notice this. I can take a 5 out of all of 10, negative 25, and negative 15. So I would do that to make the problem a little bit easier. So that's 5 times 2n squared minus 5n minus 3 equals 0. Now the 5, I'm not going to set that equal to 0. There's no n there. But I am going to factor this general trinomial. I'm going to use guess and check. Factors of 2 are or 1 and 2, so that's 2n and n. 3, it'd be 1 and 3. I want a negative 5, so I'm going to put the 3 here and the 1 here. This would give me 6n, and this would give me 1n. I want it to add up to negative 5 here, so I'm going to say that's negative 3 times 2, so it's negative and positive 1. So that adds up to negative 5n in the middle. So it is factored. So what are my two answers? Well, 2n plus 1 equals 0. Solve it. Set them equals 0 and solve. That's 2n equals negative 1. So that means dividing by 2, I'd get negative 1 half. There's one solution. N minus 3 equals 0. Adding 3 to both sides, I get n equals 3. So negative 1 half and positive 3. Lovely. Okay. Let's go on. And I think I had extraneous solutions of what? Negative 1 and 1, so I'm good with negative 1 half and positive 3. Okay. I'm going to let you guys try this one. You should get answers of 2 and negative 1, but negative 1 would be an extraneous solution. So the answer is p equals 2. Go ahead and try this one. If you do have problems with it, bring it up to me and I'll help you out with it. This problem's a little bit different. You get a word problem here. You can have one of these on the quiz, so pay attention. Brianne and Owen paint a house together. If Brianne can paint the house, a particular house, in 6 days, and Owen can paint the same house in 5 days, how long would it take the two of them if they were working together? Okay, so we're looking for time here. How many days is it going to take them working together? And that is going to be my variable, the time, the x, we'll say. And x is in days. Brianna. Let's say she had, what, 12 days to work. Well, she had 12 days to work. How many houses could she paint? Well, she can paint 1 in 6 days. So 12 divided by 6 is she could paint 2 houses. What if she had 18 days? Well, if you divide that by 6, it'd be 3 houses. Well, we don't know how long it's going to take her to paint this one house with her friend, so she's working with X days. Well, how much of the house can she paint in X days? You would divide it by 6, kind of like we were working with over here. So she can paint X over 6 of the house, X over 6 parts of the day, or parts of the house in that amount of time, whatever it is. So, likewise, if you're looking at Owen, you would be dividing by 5. So Owen can paint X of the house. If you divide it by 5, that's how much of the house he's going to paint. How long would it take them together to paint one house? So if you add how much of the house Brianna's going to paint, plus how much of the house Owen's going to paint, that would equal, well, how many houses are they painting? We decided they're painting one house, so it's just going to be equal to 1. So it's kind of a rational equation. We don't have any variables in the denominator, but we're going to solve it the same. My least common denominator is 6 times 5, or 30. Remember, this is 1 over 1. I need a common denominator so I can add the two fractions together and solve this equation. So here I'm going to multiply by 5 over 5, and that's 5x over 30. Here I'm going to multiply by 6 over 6 to get that common denominator of 30. So that's 6x over 30. You have to multiply by the same thing over here to get a common denominator, 30 over 30. And once again, everything has a common denominator. I can just solve the equation in the numerator. 5x plus 6x equals 30. And that is 11x equals 30, or dividing by 11, it's 30 over 11, or x equals 2 8/11. Or it's actually about 2.72, and that is days. So if I was estimating them, I'd say about 2 3/4 days or a little under 3 days to paint this house together. Good job, Brianna and Owen. Okay, ratios. Ratio is just a fraction. We're going to set this problem up using ratios or fractions. And it says the ratio of 16 more than a number to 12 less than a number is 1 to 3. So it's equal to 1 to 3. There's your last ratio. Is, remembering, is just equals. Now, the first ratio, setting that up, it says the ratio of 16 more than a number to 2 is where you split it. 12 less than a number. Well, 16 more than a number, that's 16 plus x. 2, that's where the fraction part of it is. Now we have our denominator. 12 less than a number, that means we're subtracting 12 from that same number. And here's our equation. Well, I can't factor anything. I'm going to solve this by, well, my least common denominator is going to have a 3, this 3 right here, number part first, and have actually an x minus 12. So I'm going to multiply this side by 3 over 3. And I'm going to get, 3 times 16 I think is 48. Yes. 48, and then 3 times x is plus 3x. All over 3 times x minus 12. Equals, this time I have to multiply by x minus 12 over x minus 12. And I'm just multiplying 1 by x minus 12, so that becomes x minus 12 in the numerator, all over 3 times x minus 12. Okay. Once again, I do have a common denominator. I can cancel it out and just solve the numerator. 48 plus 3x equals x minus 12. I would subtract x from both sides. I'm going to subtract 48 from both sides too to get all my constants on the right hand side. These cancel out, and I get 2x equals negative 60. Dividing both sides by 2, we get 30. Our answer is 30. Is there an extraneous solution? The only thing x cannot be, well, I can't have x minus 12 equaling 0, so that means x can't equal 12. There's no extraneous solution in this case. Our answer is x equals 30. Peace out, Girl Scout. Have fun doing this. Working on this worksheet 9.5. If you do have any questions, hey, just circle it, maybe watch it again. You can look at Miss Meyer and see if you like the way she does it. Mr. Johnson, he probably does it, I don't know which way he does it. I haven't looked at his yet. But if you do have questions, come see me.